Section 10.5, we're going to continue our discussion of circles, and specifically we're going to look at applying other relationships, or other angle relationships, I should say, within circles. We've already looked at central angles and inscribed angles. So the first theorem we're going to take a look at says if a tangent and a chord intersect at a point on the circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So really here's the long and the short of it is that if I look at angle A here, okay, not what I wanted. See if I can get this right. All right. So if I look at angle 1 here, the arc that's intercepted is arc BA, and so the measure of angle 1 would be 1/2 of the measure of arc AB. Really, it's the same rule as an inscribed angle. Okay, but in theory, angle 1 and angle 2 are not inscribed because again, this portion right here is not a chord of the circle, but it still follows the same logic. Again, angle 2 intercepts this chord, or I'm sorry, this arc, and so the measure of angle 2 would be 1/2 times the measure of arc ACB. All right, and so that's what we're looking at here. So example number 1 says line M is tangent to the circle. Find the indicated measure. Find the measure of angle 1. Well, again, angle 1 is just going to be 1/2 times the measure of the intercepted arc. 1/2 of 132 is 66 degrees. Okay. Find the measure of arc EFD. Now we're going to go the other way. So EFD, find the measure of the arc. Well, if I know the angle is 110, then to get to the arc, I got to double that, multiply by 2, 220 degrees. Okay, very similar to what you saw yesterday. Now this is a new theorem. Okay, there's two more theorems we're going to look at that are really different. Okay, this one says if you have two chords that intersect inside a circle, then the measure of each angle is 1/2 of the sum of the measures of the arcs intercepted by the angle and its vertical angle. Okay, in other words, look at you know that this angle and this angle are congruent, and so to find the measure of each of them, you got to average the arcs. Okay, so 1/2 times the measure of arc AB plus the measure of arc CD. Okay. Similarly, to find the measure of angle 2, well, angle 2 and this guy are the same. They intercept arcs BC and AD, and so to find them, you have to average those arcs. The measure is 1/2 times the measure of arc AD plus the measure of arc BC. All right, so this is definitely a different theorem, one that we haven't seen yet. So if I want to find the value of x, we'll understand that x and this angle are the same. So in order to find those angle measures, you have to average the arcs that they intercept. So the measure of angle x is equal to 1/2 times 140 plus 112. That's 1/2. 140 and 112 makes 252. And half of 252 is going to be 126 degrees. Okay. So that's what we're looking at there. In part B, it says find the value of x. Now understand what this one's saying. This is saying this angle is 52, so then we can find this angle measure now. 180 minus 52 is 128. Okay, so understand what you have now. Now we know our angle measure. I got to find an arc measure. So I know the angle measure is equal to 1/2 times the average of, or the sum of the two arcs. Now I got to solve this for x. I want to get rid of the 1/2 first, so I'm going to multiply both sides by 2. So I get 256 is equal to 144 plus x. Subtract your 144 from both sides, and so x is equal to 256 minus 144, which is 112. All right. So again, just some more examples. Now this next theorem are angles outside of a circle. So if you have an angle outside of a circle and both of the lines intersect the circle, okay? So if I were to give you a diagram like this, and this is kind of going to be obscure here, but if I give you a diagram like this where one of the lines intersects and the other one doesn't even come close to touching the circle, there's nothing you can do there, okay? Obviously you have the 3 diagrams here below to kind of show you the different cases you could have. But long story short, if you want the measure of an angle outside of a circle, you take 1/2 of the difference of the arcs. that are intercepted. So BC and AC in this case, okay? PQR and PR in this case. And then obviously over here, XY and WZ. So angle outside, 1/2 of the difference. Angle inside, 1/2 of the sum. So if I look at part A here, it says the measure of arc ACB. ACB. Okay, well, to find the measure of the arc, all you do is double that guy. So 2 times that is 240 degrees. Okay. Part B, angles outside the circle. So I know the angle is equal to 1/2 the difference of the arcs. So 170 minus 72. And you'll always do the arc furthest away from the angle, and then the arc nearest the angle. So x equals 1/2 times 170 minus 72 is 98, and half of 98 is 49. And finally out here, again, part C, same idea, except now you're solving for something different. I know the angle outside. I know this arc. I want to know this arc. Okay, well, we know that the angle outside is equal to 1/2 times the difference of y and 30. So same theorem, just applying it in a different manner. I'm going to get rid of the 1/2 right away, so I'll multiply both sides by 2. So 52 equals y minus 30. Add your 30 to both sides. And so now we know that y is equal to 82. So again, you have a theorem that deals with angles inside of a circle, you have a theorem that deals with angles outside of a circle, and you have a theorem that deals with angles that occur on a circle. Okay, so 3 different theorems to take a look at for today. Again, you just got to kind of keep working with these things. We'll do plenty more examples in class to make sure that you're comfortable with these ideas, and then we'll go from there.